7. And I would like to know what is the corresponding answer here. If there is a 6, 3 is equal to theta is equal to 3 is the answer. But what happens when xy to the power 7 is equal to 1? What is the answer here? And that fill in the blank was an equation, theta 3 minus 5 theta square plus 6 theta minus 1. That equation becomes very important, because once we have solutions of this equation in a certain type of fields, for each theta as a root of this polynomial of degree 3 gives us Hurwitz groups. That is, groups generated by two generators, x, y, satisfying x square is equal to 1, 5, y 3 is equal to 1, and x y to the power 7 is equal to 1. So it is in sequence of these results. Several of my students then they start working on this field, and then they started looking at x y to the power 8, x y to the power 9, and so on and so forth. And they eventually came with a general result. I remember Dr. Nazir, when he was my MPhil student, he did research on this fact that a certain type of coset group is a homomorphic image of alternating group. याद है कि भूल गए हो? कहो भूल गया हूँ. तभी that's why you kept on saying in your lecture कि ये mathematician है और मैं mathematician नहीं हूँ. To be honest, I think कहीं सवाल ना कर दे mathematical. I'm glad that you are afraid of mathematicians. हालांकि you yourself is one of them. So if you remember, your result was on coxetal groups as homomorphic images of. So they were in line of what we were doing here. So several of my students, even Dr. Asif Ali, he also did something like that. Later on, Colonel Ashik, आपको याद है बहुत से रिजल्ट. फिर हमने रिफाइन भी किया उनको. उन्होंने रिफाइन किया कि वहाँ पे 3 क्वांटिटीज़ थी और हम चाहते थे कि उन क्वांटिटीज़ को मिनिमाइज़ किया जाए. वी कीप द मिनिमम लेवल. पहले लेवल पे मिनिमम नहीं आते थे, और इसमें कोई हमारी बैड इंटेंशंस नहीं थी कि पता था कि कोई बात नहीं है और फिर दूसरा पेपर आ जाए और फिर तीसरा आ जाए. वी हैव बीन वेरी ऑनेस्ट, एंड आई एम ग्लैड टू मेंशन दैट हियर in the during my lecture, that my students have been very honest researchers. They used to put all their effort to reach to the maximum better result that they wanted to achieve, without having this intention in mind कि चलो एक पेपर इसका निकाल लेते हैं, अगले दिन इसको रिड्यूस कर लेंगे, पता है पहले से दूसरा निकाल लेंगे. They were not doing this kind of work. I'm very glad. Research is not so important than this factor, that impact factor important है, but ये factor भी important है. So we started getting now finite diagrams, and we started looking at their characters of different type. These are the samples of what happens actually. You see, this is one part of the coset diagram. This is our vertical axis, and the other side is this one. But when you take homomorphic image of this, it becomes like that. When you take homomorphic image of this, it becomes like that. So this also started yielding results which were of immense importance. Now I come to the last part of my discussion. Remember, we started with a coset diagram of infinite cases. In that we had the closed paths of various types. We reached to a very important result which told us that actually there are only 3 types of circuits that we get, 3 types of closed paths we get in this case. And all these diagrams are homomorphic images of those. When you deal with them, coset diagrams evolving out of the action of the modular group on projective lines over finite fields. So therefore, there is a need to now look at these kind of fragments. I still have 9 minutes. If you look at the diagram, if you look at this diagram, a path patch, there are 2 circuits connected together. Number have an later. Well, this is the reason. Periodic circuits we cannot deal with because they do not occur in the first place. So here we have non-periodic closed. This should be non-periodic. because we have said that we do not get periodic closed paths. We cannot. There's a mathematical logic which was explained there, although I didn't narrate. So these fragments, when do they exist? When do they exist in the finite cases? Well, there's a whole length of process. We go through that. Keep in mind the algebra working behind. And eventually, we get to this determinant, which is a polynomial. All these A's, B's, and C's are basically polynomials in R's and deltas. And if you remember, R is the trace of the matrix XY, and delta is the determinant of the matrix XY.